In this video, we will discuss various types of control charts and exemplify them in JUMP. The datasets that will be used throughout the video is the airplane data and the CLIPS 1 data. The x-axis on each of the charts shows the observations, while the attribute of the observations is on the y-axis. This is done in JUMP by selecting the control chart builder or choosing one of the other various types of charts. Displayed are the x-bar chart and the r chart. As you can see, the x-bar chart is out of control due to the fact that 3 consecutive data points are out of the upper control limits. In the r chart, we can see that there are 3 points that suggest that the system may be out of control, but we would need to do further testing. The uniformly weighted moving average chart is used to monitor small shifts in the process mean, or uses averages of consecutive observations to determine if a system is out of control. This is done in JUMP by selecting Analyze, then Quality and Process, then Control Charts, and choosing the option that you see as best fit. As you can see, the dataset used in this example is not out of control due to the fact that in both control charts there are no consecutive data points that are above or below the upper and lower control limits respectively.
We created a Pareto chart using the CLIPS 1 data table. The Pareto chart contains both bars and a line graph. Individual values are represented in descending order by bars. The cumulative total is represented by the line. In SAS JUMP, we went to Analyze, Quality and Process, and created the Pareto plot. This is the Pareto plot that we created in JUMP. You can see the green individual bars that represent contamination, corrosion, doping, metallization, miscellaneous, oxide defect, and silicon defect. You can also see the line that represents the cumulative percent that increases to 100. The cumulative line corresponds with count on the left, and that is how we use the 80-20 rule to tell if it is out of control. We will now analyze the results of the charts and discuss how to determine if you are out of control. For the X-bar chart, it is out of control by 4 points. 1 is below the lower control limit, and there are 3 that are above the upper control limit. The R chart shows that there are 2 points that are below the lower control limit, but they are not out of control. However, there are 2 points well above the upper control limit and 1 point that is very close to the limit. For this, we would say that they are out of control. These days, the variation of production is out of the range that the production needs to be in order to meet customer specs. The R chart shows that there are 4 points that are out of control. 2 are below the lower control limit and 2 are above the upper control limit. This means that these days, the variation of production was out of the range of production that is necessary to meet the requirements. Because we know that the R chart is out of control, we know that the X-bar chart will also be out of control. The exponentially weighted moving average chart requires that the weight is greater than 0 and less than or equal to 1. The limits are a specified multiple of sigma that is predetermined. This is how we can tell if the chart is out of control. Looking at the charts, they are in control as all the points are within the limits. The Pareto chart, the 80-20 rule tells us when we are out of control. While looking at the cumulative line on the chart, it corresponds with 7 causes, so 100 divided by 7 is about 14%, which is less than 20%. This shows that we are within the 20% and not out of control. If we decrease the causes from 7 to 4 and divide by 100, it would be 25% and we would be out of control.